Hello, everyone. A very warm welcome to this session where I will be talking about the lessons learned from building a serverless notification system. So, I am Srushith Repakula, the head of engineering at a startup called Confab. So I'm also an AWS Serverless hero and a co-organizer of the Serverless group, which is a meetup group here in Bangalore, one of the largest serverless enthusiast meetup group across the globe with approximately 10,000 members in the community. So let me get started. So what is it that I'm going to share today is the first one is what did we try to solve? And then how did we solve it? Why serverless? Of course, you can expect me from a serverless hero. I will obviously be talking about serverless. What are the various challenges, problems that were encountered and how we solved them, and the unconquered challenges. So I will be sharing the experiences that I learned as we built a highly scalable serverless notification system. So what did we try to solve? So as I said, we wanted to build a highly scalable notification system that can deliver notifications to hundreds of thousands of recipients. Now, these can be notifications in terms of email, SMS, or WhatsApp, or could be in-app notifications as well. Now, we wanted to make sure that these notifications are run as campaigns, and these campaigns should be able to be scheduled or be launched instantly. And we wanted to make sure that the application handles duplicates apart from the scalability factor, and also make sure that we have real-time analytics on the deliverability, the open rate, click rate, bounce rate, and the various aspects of any notification campaigns that you would launch. Without analytics, there's nothing, right? You need to have data back to understand what you're doing. Now, this is on a high level how we solved it. Of course, you can see a lot of these AWS serverless services that are used. I will be walking through a few of them today in this session and sharing the various trade-offs and the decision-making steps we took into the picture while we were selecting a particular service for a particular scenario. So on a high level, AWS Lambda, of course, the compute service, is the hero of the application. Then we have API Gateway interacting with the client side of things, the UI, the mobile app, and whatnot. And then we have Amazon Cognito for authentication and authorization, handles everything from login, sign up, forget password, and everything. We have Amazon Simple Queue Service, which is called as the SQS. And then we have the data sources, Amazon Aurora and Amazon DynamoDB. Then we have SES, which is the simple emailing service, and SNS. So the SES will be used for sending emails, whereas SNS will be used for sending SMSs to the recipients. And then we, of course, have another Lambda function. We have EventBridge and webhooks as well. So EventBridge is an event bus service available on AWS. I will be talking about why we chose EventBridge and what is the advantage or the various perks it brings into the application. And then I will be talking about the various nitty-gritty details when it comes to the scalability factor of the application and how we conquer them. So as I said, these are the various AWS services used: Cognito, API Gateway, Lambda, DynamoDB, SQS, Amazon Aurora. So what we used was Amazon Aurora Serverless for the database to make sure that the database scales automatically without much of a challenge, and then SES and SNS for the notifications. So why go serverless? That could be one of the questions, right? So we are a startup. And for a startup, there are two very, very important things, as I'm sure all of you would know. The first and the foremost is the cost. Why? Because obviously we do not have money. So we have to make sure that we are as much careful as possible with respect to our cloud bills. So serverless felt like a very natural choice for us to get started with, because it is pay as you go. You only pay for how much you consume. And there are no servers to manage, obviously. So it made perfect sense for us, especially coming from the startup world. And the scaling factor, of course, everything scales automatically. Terms and conditions applied because there are certain throttling limits and conditions that we need to take into consideration. I will be covering a few of them along with this session. And then built-in fault tolerance and bring your own code. So you might have a piece of code that you would probably want to migrate into serverless. It is possible, but the most important thing to keep in mind is not the code. It is the mind shift of the developers from a normal server world into the serverless, where here everything is stateless, everything is eventful, everything is event driven. So you as a developer or an architect need to have that mind shift. One is the cost factor, as I talked about, and the second one is the scalability factor. Both of these were two main reasons for us to choose serverless. Confab, the startup where I work as the head of engineering, we are completely serverless, and these are the two main reasons for the same. So what were the various problems and challenges that we faced while we built this? First and the foremost is the deliverability of emails and domain reputation. So let me take a quick second to explain what Confab is. So Confab is an event ticketing platform where where organizers come, host events, people buy tickets, and organizers would want to communicate to their participants about various updates of the events and everything. So email communication or communication from the organizer front to the participants is a very, very key aspect of the entire application. So and email being the primary mode of communication. So this entire talk, I will be talking about the various challenges for email and how we solve them. Most of it is relevant for any type of communication out there, SMS or WhatsApp for that matter. So the deliverability of emails, ensuring that the emails are reaching the participants, the recipients, is at most important, and especially when it is at scale, right? So the next one is SQS. So we have a queuing service. Then the first choice that we had to make is, do we go with a FIFO queue or a standard queue? I'll be talking about that. Throttling limits, as I told you, we are looking at scale, right? So we want to make sure that the services that we are using can automatically scale up and down as and when the requirement happens. For example, number of emails sent per second is a throttling limit that we need to take into consideration and build or work around it. Scalability, cost, and time to finish the campaigns. If I'm launching a campaign for 10,000 recipients, I want to make sure that it is done within a few seconds or a minutes at max. It cannot take several minutes, right? So it is important to make sure that the campaigns complete in time. Lambda functions, maximum timeout of 15 minutes. If any of you would have worked with AWS Lambda, you would know that there's a maximum timeout of 15 minutes. And scheduling of campaigns every minute, to the minute. So I'll be talking about all these challenges and how we solve them along the way. First of all is the deliverability of the emails and the domain reputation. So as I talked about, domain reputation is the most important thing from an organizer's perspective, because it gives them the confidence that their communication is reaching the participants. Right? So how did we take care of it? As I told you, we use a service called SES, and with any other emailing service out there, this is a concept. There's something called as a dedicated IP, and there's something called as a shared IP. So whenever we are using a cloud service for sending emails, of course, it is originating from a server, right? And there is an IP address for that. So all email receivers like Gmail or Yahoo or any of the providers out there, Outlook or any of them, they maintain a reputation of the domain, and it is the domain's responsibility to maintain the reputation. So they keep a track of the reputation, right? So what happens in the shared IP model, which is the default mode, is there are multiple consumers of the service who are using the same IP address. So basically the service provider, let's say SES for this example, will use the same IP address for different AWS customers and send out emails. So what will happen is, if at all customer B and customer A are both sending emails, and customer B is sending emails that are probably promotional in content or spammy in nature, what would happen is the IP address's reputation would go down, resulting in a problem for reputation for customer A as well, who's potentially using the shared IP address. So this was one of the problems that we understood. And how did we solve it? Is we moved to dedicated IPs. So any service provider, SendGrid or SES or any of the top service providers out there, have this feature available, where with dedicated IPs, what is the advantage is that the IP is only designated, assigned to you. So it is completely your responsibility to make sure that the reputation of the IP address is maintained. Now, so therefore, it is solely Confab's responsibility in this case to maintain, and we are not impacted by any other's reputation. So with Amazon SES, there are three aspects to it. One is a standard, managed, and the last one is bring your own IP address. With standard, what happens is it refers to the dedicated IP addresses that we manually set up, right? Where we have to take care of warming up the IP addresses, scaling them up and down as and when the traffic comes up. Then is the managed service, managed option rather, where AWS will completely take care of it. And all you have to do is provision the IP pool, and AWS will make sure of automatically warming up and scaling up and down the IP addresses as and when it is required based on the load of the application. And then we have bring your own IP addresses. So if you have your own IP addresses, then you can bring those into Amazon SES as well. One of the biggest advantage of this option is if you had already maintained IP addresses, then you probably have a reputation for that. So you can basically continue from there instead of starting from scratch. The next challenge is the heart of it, the queuing service, right? So there are two options on AWS SQS. One is the FIFO queue and the next one is the standard queue. So as FIFO states, what happens is the messages are ordered. That means the messages are processed in the way that they are pushed into the queue. Whereas in a standard queue, as you can see in the diagram here, the messages are pushed in this order 1, 2, 3, whereas they may not be processed in the same order. So the order is not persisted or maintained. Therefore, you have to choose which kind of a queue that you want for your application. If ordering is important and making sure that duplicates are not processed, then you can potentially go with SQS queue. Whereas if you want high scalability, high throughput, then you can go with standard. We'll talk about a few things. So between SQS and standard, this is the case for FIFO that we fit. First of all, handling of duplicates and order. Let's say you have a campaign that has to be launched for 1,000 people, 1,000 recipients. Then we push all the 1,000 details like email addresses into the queue one after another, right? And then what happens is with FIFO queue, automatically order is maintained. And the biggest advantage of this is we know that once the 1,000th message is processed, we know that everything ahead of that is processed, so we can mark the campaign as completed. So keeping a track of the status of the campaign becomes much more easier because ordering is in place. The next one is the duplicates. So with the FIFO queue, duplicates is managed by AWS itself. So that's another plus or another point to FIFO. Easier understanding of the status of the campaign, as I talked about. Unbatched throughput of 300 messages into the queue. These are the throttling limits, right? Batch transactions per second in FIFO is 3,000. Batch transactions per second for high throughput FIFO. So this is another setting on FIFO queues where you have to enable it. So then it goes to 70,000 messages per second. And then in-flight messages per queue is 2,000. Of course, a few of these limits can be increased by raising a service request with AWS. So as you can see, the numbers are decent, but not of the highest in numbers. So let's go to the next one, the case for standard. In-flight messages per queue by default is 120,000. So significantly higher number when we compare it to FIFO. Faster to process since they're not in order. Because now what you can do, you don't have to wait for your previous message to be successful to make sure that the current one is successful. So what you can do is you can batch them up and parallelly process them. So that is a very big advantage because now you can run your campaigns much faster than what you would do in a FIFO queue. And it is much more cheaper in comparison to FIFO queues. So that is a standard queues. Now, what do you think? Which one should we choose? Is it going to be a FIFO queue or is it going to be a standard queue? I already talked about what we want. I presented my case for FIFO. I presented my case for standard. What do you think we chose? Let us know. So it is standard queues that we chose. You might wonder, if you look at this, my standard queue slide only had 3 points, whereas my FIFO had almost 6 points. But why did we still choose standard? So this is why it is. So all the standard queues increase complexity in the application layer because we have to implement for idempotency. As I said, in FIFO queues, duplicates are handled, whereas in standard queues, you have to make sure that the idempotency is built into the system, because standard queues promise at least once delivery. And extra processing for fetching the campaign details, because now, if you think about it, they are not ordered. So imagine there are 10,000 messages into the queue and all of them are being processed in parallel. How would you know that the campaign is completed or not? So you have to put in a little bit logic into your application layer, increasing its complexity. But still, why did we go ahead is because FIFO has only a 5-minute deduplication interval. I was talking about how FIFO handles duplicates, right? But that duplicate period is only for 5 minutes. So it was not really sufficient for us in certain use cases. And the second one is slower when hundreds of messages are pushed within the same group. So what happens with FIFO queues is that you group the messages into a group and the order is maintained within the group, right? So now, because you're processing them in order, especially when there are higher number of messages, your capability to process the campaigns faster goes down. So your campaigns essentially slows down. So this way what happens is it'll take longer, which is not really what we want. And of course, the cost factor, I told you, right? Startups. Then throttling limits, the next challenge that we hit. Throttling limits of the notification service providers. Throttling limits are everywhere. So when I talked about serverless, I told you that there's terms and conditions, right? So a few of those are these. So with SES especially, what happens is there's a daily sending quota. That means that there's only a number of emails that you can send in a 24-hour period. The second one is a maximum send rate, which is basically the maximum number of emails that you can send per second. Right? One can exceed this quota for short bursts, but not for sustained period of time. So what will happen is AWS will throttle the request. So you'll not be able to send the email for that instant until the requests go down. So we have to make sure that we work around these two limits. The first one is slightly easier because it is something that is at the region level. You can say that you can get AWS increase that limits. The second one also, you can get the limits increased, but you have to make sure that your application works around it because we are talking about scale, right? So how did we do that? The first one is reserved concurrency. So if you remember the architecture diagram that I shared, at first we have the SQS queue, and then we have the Lambda function, and at the end we have the SES service. So what happens is the messages are pushed into the queue, and Lambda functions are getting triggered, and the Lambda functions are using SES to send the emails, right? So now my SES, the third component in my architecture, has throttling limits. So what I have to do, I have to make sure that my Lambda functions are not too many in number so that my SES does not get overwhelmed. So what we have done is there's something called as reserved concurrency. So what is reserved concurrency? It is the concurrency limit that is reserved just for the Lambda function, ensuring that execution environments available and not shared with the account level settings. So what it essentially means is that I am telling that only these many instances of this Lambda function can come up at any point in time. Now, let's say, for example, my SES has a limit of 100 emails per second. I can limit my Lambda functions reserved concurrency saying that only 100 Lambda functions can come up per second. So that way what will happen is, even though my SQS queue has thousands of messages, there are not so many Lambda functions that come up. Therefore, only 100 Lambda functions come up per second, and they call SES only 100 per second. So this way we were able to control the number of Lambda functions coming up, therefore protecting the SES. And then this basically makes sure that the maximum number of execution environment instances are configured, and these are throttled when the reserved concurrency limit is reached. So whenever we cross 100, AWS automatically throttles the request for Lambda. But having said that, this was not really very ideal solution for us, because Although I wanted to make sure that this Lambda function, which is getting from the SQS queue, is triggered, are only 100 in number. But this kind of created a little bit of a bottleneck for us because there were various other services that are used in our architecture, which is talking to this Lambda function, right? Which is used for sending the emails. Now, all of them are being limited to 100 per second. So what we did was, if you take a step back and think about it, what do you want to do? You want to make sure that only 100 emails are sent per second, right? So what you can do, instead of having the limit at the Lambda function level, we can have a maximum concurrency limit at the SQS level. So what will happen is I'm narrowing the funnel that goes from SQS into Lambda functions, making sure that only a smaller number of messages are pushed from my queue to the Lambda function. Therefore, I have moved my concurrency limit from a Lambda to the SQS. This was an advantage because if there are any other services that would want to talk to my Lambda function and send out the emails, it can do so. So whatever concurrency limit that I talked about at the Lambda function level, we moved it to the SQS level, therefore giving us a little more flexibility if other services in our architecture would want to talk to it. The next problem is scheduling of the campaigns every minute, right? So as I told you, Confab is a platform which is used across the globe, right? So that means that we want to make sure that our organizers have the capability to launch the campaign at any minute across the 24-hour period, right? So what are the challenges? First of all, the campaigns can be scheduled to the minute. So let's say if someone wants to schedule a campaign at 2:37 p.m., they should be able to do so, right? And then scalability of the scheduler service, because there could be hundreds and thousands of campaigns that are scheduled across different events organizers, right? So what did we do? One of the easiest solution is to run a cron job, right? So with a cron job, what would happen? We can create a cron job that runs every minute and pick up, look at the schedules in the database and see if there's any schedule that is to be run at the minute, pick it up and run it, right? But this was not the most cost-effective or ideal solution, because we are running a cron job every minute, even if there are no schedules that are probably going to be run at that minute, right? So unnecessarily too many schedules are to be run, right? And this also increases the application complexity, because you have to write another cron job, maintain it, and everything, right? So anything that you want to avoid is complexity that you would want to avoid, right? So that's where EventBridge comes into picture. So EventBridge is an event bus service available on AWS. It's a serverless service, so it provides a lot of capabilities. So in the interest of time, I will be talking about the EventBridge scheduler. So what it does is it gives the capability for us to schedule millions of schedules. It can either be one time or a recurring schedule, and we can schedule it to the minute. So what happens is, when an organizer schedules a campaign on our platform, we go ahead and create something called as a EventBridge schedule, and we have a target as a Lambda function. Now, the input to this schedule, the input to the Lambda function is configured in the schedule. And over there we mention, okay, this is the organizer, these are the email content or WhatsApp message that they want to send, and these are the list of people they want to send it to. So we simply schedule that, and AWS EventBridge service will automatically make sure of triggering this a target. The most important advantage over here is we do not have to write any cron job, and we are not running it every minute, but still our application has the capability to schedule millions of schedules using this service. And the next one is it gives us the capability to connect to over 260 services on AWS. I mean, talk about the range of things we can achieve, right? So that's pretty much it from my side. So I hope I had given you a bit of an understanding of how we solved the various problems and challenges that we faced while building a serverless notification service. I'll be more than happy to answer any of your questions. Please stay in touch. These are my links. I'll be more than happy to talk about AWS or serverless in general. Please do reach out to me if you have any questions. Thank you for having me here, and thank you for the opportunity.